Hello, so today let's learn about something called quadratic equation. And so what is meant by quadratic is that quad stands for something squared like x squared. It is also called as equation for something of second degree or the degree 2 in American form. The standard form looks like ax squared plus bx plus 3, which is right here. A, B, C's are all known values, but a can't be 0 because it will literally turn into a linear equation. So x is a variable that we are trying to get. So this is all the target is all about for the quadratic equation. And they are basically two solutions generally for quadratic equation. We normally call them, I normally call them, personally call them alpha and beta and the Greek form. But some of you will call this as x1 or x2 as a two solutions, but I just want to call it as alpha beta because it just looks unique and it looks great. And there are, for instance, I just want to tell you something. For instance, cubic equation has a general solution, and as like linear has a generally one solution available. So the quadratic equation just basically has two general solutions, but it could also have a one or two solutions that are actually same. You just normally say as one solution, and it could also have a non-solution available as well. For example, you can see the example of the quadratic equation saying x squared plus 3x negative 4 right here. In order to solve this x, you need to use the three methods I just have written down here. Factorizing method is the first one, using quadratic formula and using a substitution method is going to be second one, and then finally it's going to be using complete square method. And I'm not going to use those methods step by step, so stay tuned and let's get started. The first method is going to be called as factorizing. So what is meant by factorizing is to make something looking like form like x negative alpha times x negative beta equals 0. So the alpha and beta is just going to be a two solution for this particular equation. And how to turn, the concerning thing is the how to turn this thing to this thing when you have a quadratic equation. And let's do it now. And it could be really hard for some of you guys if you have never learned the quadratic equation before or factorizing the quadratic forms. It could be a bit concerning to you guys, but I'm just gonna explain step by step, so it could be getting a little bit easier. I hope. My goal is to make everyone to actually do the factorizing. So let's actually get started. So the example was x squared plus 3x negative 4 equals 0. So what basically you need to do is something looking like this. Well, I just told you, something like we need to turn this into this. So basically the method that I will recommend to you guys is just using the crossing method. So x times x, so this is x times x makes, oops, that looks like something different. X times x makes x squared. And let's say this is alpha and beta, negative alpha, negative beta, because it's negative sign over here. So let's say negative alpha and negative beta. So negative alpha times negative beta is making negative 4, sure of these signs, and negative alpha plus negative beta should make 3, or positive 3. So this will eventually turn into negative alpha minus beta, which is 3. So it should be satisfying this simultaneous equation, and you should be actually guessing what the alpha and beta is going to be. So let's just actually guess. So let's say alpha's 4 and beta is negative 1, because 4 times negative 1 makes negative 4. So let's actually use it for this one, negative alpha, negative beta. Substitute these values in and let's see if it actually matches to 3. So negative 4 positive 1 will make negative 3, which is not actually satisfying this term. So let's say alpha is negative 4 and beta is 1. And it is actually satisfying the first term, which is going to negative 4 times 1 makes negative 4. And let's actually substitute it here. So it'll become negative 4, which will turn into positive eventually. Negative 1 equals 3. So positive 4, negative 1 equals 3. Oops. And that is actually satisfying. So here we go. So we had found that out that alpha is negative 4 and beta is 1. So substitute it on here, then it'll eventually come 4 and negative 1, right? 4 times negative 1 makes negative 4. 4 plus negative 1 should make 3, which is 4 minus 1 makes 3. So turn that into this. So we have found that alpha is negative 4 and beta is 1. So also substitute in here. It will become x positive 4 times x negative 1 equals 0. So what this is meant by is that it's actually timesing each other to make a 0. So guys, 0 times 0 is only going to be 1 that actually makes 0. I know like 1 times 0 and stuff like that should also make a 0, but we normally say 0 times 0 is 0. So it eventually becomes x plus 4 as 0, or it's not and, it's or x negative 1 becomes 0, and x equals negative 4, and x becomes 1. If you just move these to the right side of the equation, this is going to be your solution using the factorizing method. But not all of the equation, which we will be solving some problems later on, but not all of the equation, the quadratic equation, is not capable of factorizing. If you can't factorize those terms, you need to turn into quadratic using the quadratic formula by substitution method, and let's start that now. So the second method, oopsie, oh, I don't know why that happened. So let's use the second method, just erasing all of these stuff. They'll just take time. So we just accomplish doing the first method, so I'll just put a check there. And the second one is going to be using quadratic formula. So yeah, this is equation plus 3x negative 4 equals 0. And the quadratic formula, let me actually show you how to do it. So the quadratic formula is something looking like this: 2a minus b plus minus, because there should be eventually two solutions available, root b squared negative 4ac. You do have to memorize this in terms to get those solutions. Well, you're just taking exam papers on GCSEs, so you should be memorizing them anyway. That's the thing I just want to tell. So the standard form is looking like this: ax squared plus bx plus c equals 0. For this one, the a is going to be 1, because we don't really say 1x squared, we just say x squared, right? That is really basic thing about all those equations and stuffs. And b eventually becomes 3, and c becomes negative 4. Get it? Yes, because these ones are going to be turning to these. Okay, so for this one, we got the values, so substitute in this formula and you should be getting x. So let's actually try it. So x is 2 times 1, because a is 1, negative b, which is negative 3, plus minus root b squared, which will become 3 squared, which is 9, negative 4 times a times negative 4. And there we go. And that is going to be the form. And let's actually simplify them. So it will be 2 times 1, which is 2, negative 3 plus minus root. So negative 4 times 1 times negative 4 is 16, right? And 16 plus 9 is becoming 25, sorry. And if you simplify that, root 25 is basically 5, so just turn them into 5, and it'll be looking like negative 3 plus minus 5 divided by 2. And actually we need to divide this by 2, by negative 3 plus 5 divided by 2, and negative 3 minus 5 divided by 2. And you do get these two solutions available. And if you simplify them, the x becomes 5 negative 3 is 2, and x becomes 1 for this one, and negative 5, negative 3 becomes negative 8, and negative 8 divided by 2 becomes negative 4. And this is your two solution, right? And this is going to be the two solutions. What the heck? It's going to be anyway the two solutions for this typical quadratic equation. And let's do the final method. Sorry for the noise there, it's just a bit annoying. Really apologize for that noise. It's just something that's just running on the vacuum. So we did the quadratic equation. quadratic formula, using quadratic formula, and I just take a check here and check as here as well. And then finally that we are going to do the using complete square method. So basically the third method, x squared plus 3x negative 4 equals 0. So the third method is going to be the complete square method. So let me show you guys. So put all those x, like in a linear equation, you put all the x's, unknown variables, to the left side of the equation, and while you put all those known variables to the right side of the equation, and you do the same thing as like that. So x squared plus 3x becomes 4 because you move this to the right side of the equation, and it looks something like this. But you need to make it in the complete square form in order to get the x. So what I meant by that is this: there should be actually something, let's just say it's plus c. So c should make factorize something looking like this: x plus a squared. So okay, so let's say there's something looking like this: ax squared plus bx plus c, and it turns into x plus, oh no, it looks something like this. Oh, okay. No, okay. Sorry, not this. So ax squared plus bx plus c turns into none. Actually, let's say x squared plus 2x plus 1. There is something looking like this, and this actually turns into x plus 1 times x plus 1, and that actually eventually means x plus 1 squared. And this is what I meant by complete square form, something looking like this. So basically, if you want to get the c for this one, the formula for is that c is b divided by 2 and square the whole thing up. So it is basically ax squared plus bx plus c, right? And the c is the one that we are trying to get for this one. I think I'm explaining too complicated. Okay, let's just erase that all of them. So ax squared, so the b is basically 3 for here because it's the x coefficient, and b becomes 3, and substitute that value in order to get a c as a complete square. So 3 divided by 2, and just square the whole thing, it'll become 2 squared and 3 squared, and 9 divided by 4 is going to be the c, the value of c. And if you put that, actually x squared plus 3x plus 4, 9 divided by 4, and just put a brackets on, but it should actually minus 9 divided by 4 because there wasn't actually 9 positive 9 divided by 4 on this equation, so we should actually minus them in order to actually get the same equation, and it becomes something like this. So if you actually factorize them, it'll become something looking like this. I think you guys, I'm not quite sure if you guys get this, but I hope you do. It looks something like this, and this should be moving to the right side of the equation. This method is really advanced, so if you're the one who is actually learning this for the first time, just use those two methods up there. If you're actually looking forward to learn some advanced quadratic equations, you should be able to use the third method as well. I'm just doing that now. And just do 4 plus 9 divided by 4, and this should be oh no, looking like this. So it should be something like this, right? And the equation is looking something like this. Okay, let's just do this. Squared equals 25 divided by 4. And if you actually just put the square root for the both side of the equation, it'll become x plus 3 divided by 2. It becomes root 25 divided by 4, which is 5 divided by 2. Oopsie. And if you this is actually a linear equation, but I forgot one thing, sorry for that. But if you put a square root on the both sides of the equation, there should be actually plus minus sign going on. Root 25 divided by 4. And if you actually simplify them, it'll become plus minus 5 divided by 2. And you actually need to separate those two. So it'll become x plus 3 divided by 2 becoming 5 divided by 2, and x plus 3 divided by 2 become negative 5 over 2. And if you get those solutions, you should get the same solution I did for those two methods, which is to this minus this, because you move right side of the equation, getting 1 for this side, and for this one, negative sign, negative, negative, negative 4. So you get x as 1 and x as negative 4 for this one, which is actually right, gets all the same values even using all those three methods. So this is basically these three methods to solve the quadratic equation. And let's move to the second section. This is not it for the quadratic equation. I just want to tell you one more thing about this. So let's move on to this screen. Here we go. So this is called discriminant equation, or you can call it as discriminant equation. So to determine whether the quadratic equation has two different real solutions or one real solution or no solution as well. So basically this one is just to determine if this quadratic equation has two answers, one real solution or no solution. You can actually call the non-solutions as imaginary. It also contains the imaginary units for the non-solutions. So let's actually start them. So basically, if you look at the quadratic formula, it is something like this, right? But in here, inside the root, it is b squared negative 4ac. So basically, inside the root, if you actually get the higher, if you get the positive value, the root is actually real. I mean, it is a number. But if you get a negative inside the root, there shouldn't be any solution, because, for instance, if there's root to negative 1, there is no real answer, because root negative 1 just doesn't make sense. Because if you square something, there is nothing going to be making a negative. Because if you square something, there should be only positive values available. So this is making no sense, so which means it doesn't have any values available. So let's get started. But what if b squared negative 4ac gets 0? This means that it only gets one solution, because this plus minus becomes 0. So plus minus 0 just doesn't make sense at all. And it'll become just negative b divided by 2a, which is actually same for the complete square formula, which I just told you guys on the third method, and this is the formula. And this is going to be the discriminant, and let me show you some examples. So for instance, I have an equation called x squared plus 5x, let's say 3x plus not quite sure. Let's say 8x plus 16 equals 0. So I want to determine, I just want to know if this has a one solution available, or two solution available, or three solution available in here. So this is basically formed like ax squared plus bx plus c, and the a for this is 1, b for this is 8, and c for this is 16, right? So substitute onto the b squared minus 4ac, okay? So 8 squared negative 4 times 1 times 16, and let's see if it's 0 or bigger than 0, or if it's less than 0, which is negative. So 8 squared is basically 64 minus 16 times 4, which is negative 64, and this actually makes 0, which means that this quadratic equation has only one solution available, and that is how you use the discriminant equation for. And this is going to be the basic how you actually use them, and let's move on to some harder questions for the quadratic equation. So I just made up some few example questions. From now on, let's see and let's actually try to solve these problems. So I'm just gonna write with purple pen because I like purple. So example questions. So the number one says 5x squared plus 6x plus 3 equals 0. Find the value of x. I'm really sorry for that noise. It's just really annoying, disrupting the video. So whatever. So it says to solve find the value of x for this one. For this one, the a is 5, b is 6, and c is 3. Yeah, because of this term. Satisfying this term, right? So a is 5, b is 6, and c is 3. So for this one, you can also, I'm not quite sure if you can use a factorizing method, but for this one, the easiest way is just to use the quadratic formula. So it'll become x equals 2a negative b plus minus root b squared negative 4ac, and substitute these values in, which will become 2 times 5, and negative b is negative 6 plus minus root b squared, which is going to be 36 minus 4 times 5 times 3. And if you simplify them, it'll become 10, negative 6 plus minus root, square root, 4 times 5, negative 4 times 5 is negative 20, negative 20 times 3 is negative 60. And 36 negative 60 is actually less than 0, which means this equation basically literally has no solution. So the answer for this is no solution. But if you know those complex numbers, complex units or imaginary units, you can find the solution by putting those imaginary units. So let me show you how you actually do that. So calculate that. So 16 negative 36, which will become for negative 24, right? Negative 6 plus minus root negative 24 divided by 10. But negative sign, just negative root negative 24 just doesn't make sense at all, because something squared can't make negative. So for this one, so I stands for root negative 1, so minus 24 just becomes root 24i, so you write like this. And this is the answer, but you should have to rationalize this, which will become 2 root 6. So the final answer for this is actually 10 negative 6 plus minus 2 root 6i. And the I will be actually making a video next time about the complex units. And let's actually move on to the second question. So basically what I just want to tell you is that this just doesn't have us real solutions. So let's move on to the second question. Let's just erase all of these. I don't know, let's just actually leave them. The second question. Oh yeah. So when x squared plus 2 root 2x negative 6 is 0, the x becomes negative 2 plus minus 2 root 2. And prove this statement. So this question is basically saying to prove this statement whether it is right, true, or false. And what you have to do is just substitute in the quadratic formula, because if you have the variable with the rational units, you can't actually factorize them with the whole numbers. So let's just basically directly use the quadratic formula, which was looking like this. 2a negative b plus minus root b squared negative 4ac. So basically a is 1 for this one, b is 2 root for this one, and c is negative 6 for this one. So substitute those values into this quadratic formula and let's get started. So x becomes 2 times 1, so it's just basically 2. Negative 2 root 2 plus minus root b squared, which is going to be 8. Negative 4 times 1 times negative 6. So let's simplify those. Let's simplify them. So it'll become 2. Negative 2 root 2 plus minus. So if you simplify this, negative 4 times 1 should make negative 4. And negative 4 times negative 6 is becoming 24. Positive 24. So 24 plus 8 becomes 25. 32, right? Square root 32. And it's 32, right? And if you actually let me check if this is actually capable of rationalizing. So let's get out some numbers on the root. 8 2 4 2 2 2. Oopsie, 2 2 2 2 2 2. So basically 2 it's becoming 4 root 2. So x is basically 2, looking like this, plus minus 4 root 2, and you can actually simplify them. 1. So solution is x is negative root 2 plus minus 2 root 2 for this particular question. And this is how you solve the quadratic equation while the coefficient has the irrational units. And I think that wasn't that hard at all. And let's move on to some bit harder questions. So the number 3 says determine whether negative 3x squared plus 5x equals 5 has 2 different real solutions, 1 real solution, or no solution. So basically this is basically telling you to use this. Where are you? Discriminant equation. Well, I just told you. So let's use that. So basically, it was looking b squared negative 4ac, right? This is looking like this, right? So let's actually substitute those values. But before that, we need to turn them into the standard form, which is looking something like this. And move all of the variables to the left side of the equation. So it'll become negative 3x squared plus 5x negative 5 equals 0. But this is not it. You can actually just substitute the values directly, but I suggest you guys to turn negatives to the positive for the coefficient of x squared. So it'll become 3x squared negative 5x positive 5, which is 0. And substitute. So A is 3, B is negative 5, C is 5 for this one. So substitute those values and let's see if those values, if this is going to be more than 0 or less than 0, or if it's going to be just exactly a 0. So let's get started. B squared negative 5 squared negative 4 times 3 times 5, which is 25 minus negative 4 times 3 is negative 12, and negative 12 times 5 is going to be negative 60. So it's negative 60, and which is actually less than 0. It's less than 0, so the solution for this one is that this quadratic equation has real solutions. And this is going to be the answer for this third question. And let's move on to the final question. This is really harder. You need to actually think of it before solving this question. So let me just divide this. So it says number 4, harder. Solve x power of 4 plus 13x cubed squared plus 36 equals 0. Man, but this is actually another quadratic equation. This is actually the 4th degree equation. How are you supposed to solve this? There is actually a simpler way. Let me just show you guys. What if you say that x squared is just large x, the capital X for now? So let's say as that like that. So let's say x squared is the large x. And the large x, and it will become large x squared plus 13 large x plus 36 will become 0. So for this one, it's x squared brackets on squared. So this is actually large x squared. And here we just made the quadratic equation by just turning x squared into the capital X. And let's solve this equation by factorizing. But if you can't factorize them, you will have to use the quadratic equation in order to solve them. So let's see if this can be actually factorized or not. I'm just thinking of them, so let's actually try it. So large x times large x makes x squared, large x squared. And let's say 4 times 9. See, 4 times 9 makes 36, positive 36. And 4 plus 9, which is going to be positive 13, actually satisfies this as well. So this is the right form. So it's going to be basically large x plus 4 times large x plus 9, which is 0, and we finally factorized it. Yay, hooray. And now what we have to do is that this is all 0, right? So x is basically negative 4, or the large x becomes negative 9. But what we actually want to get is the small x, the smaller case x, right? So turn this back into here, and it'll become x squared equals negative 4, or x squared equals negative 9. But for this equation, let's actually put square roots on both sides. X becomes plus minus root negative 4, or x becomes plus minus root negative 9, which you have absolutely no solution for this particular biquadratic equation, but you can actually write this as the imaginary unit form. So looking like, so root negative 4 is becoming 2i, and root negative 9 is becoming plus plus minus root negative 9 is becoming plus minus 3i. And this is going to be your final solution for this fourth question. And thank you for watching this video. I know this was really hard, and I was actually just going through all those quadratic equation. And please subscribe and put likes on our channel, and I will be meeting you at the next video. Thank you for watching.